In this video, we're going to look at the 30 degree, 45 degree, and 60 degree special angles that we developed earlier and see how to use those angles in conjunction with the unit circle to generate additional special angles. So before we get into that, let's look at the basic concept is that if we have any quadrant 1 angle, any quadrant 1 acute angle, we can reflect that angle, the terminal side of that angle, in the y and the x axes to generate additional points in the xy plane. So what we're supposing is that we know the point xy in quadrant 1 that corresponds to the acute angle theta. And we could take this terminal side and reflect it in the y-axis, and if we did that, it would reflect over to here. The terminal side would also reflect over the y-axis, and we get this nice supposedly straight line. I'll try one more time before I give up. And the angle theta reflects over to here, so this angle winds up being theta. And so what we notice is that for this terminal side, theta is the reference angle, and we actually get an angle right here that would be 180 degrees minus theta. So we could actually, if we knew theta, we could calculate the angle that we generate when we reflect this terminal side over this axis. The point xy reflects over, and what we want to notice is that in quadrant 2, the x is going to be the opposite of what it was in quadrant 1. We have positive values of x here, negative values of x here. So if this happened to be 5, now it would be negative 5. It's going to be the opposite of what it was. But the y value is still above the x-axis, so the y value will not have changed. I could also take this point and reflect it in the x-axis. So we could reflect it through the x-axis. So this is a perpendicular reflection line. This line up here is also perpendicular to the y-axis. So reflect this point down. And the x value, if it's positive in quadrant 1, it's also going to be positive in quadrant 4, right? Because we're to the right of the y-axis, so the x value wouldn't change, but the y value, by reflecting over the x-axis, would now be a negative value. This terminal side would have reflected downwards. And we wind up associated with the angle, the rotation angle here would be a negative theta, or we could do an angle like this, a coterminal angle, that would be 360 degrees minus whatever theta is. It turns out that theta is when we talk about the positive acute angle that we make with the x-axis, theta is once again the reference angle. So if we start with the key is here, so we start in quadrant 1 with an acute angle. That acute angle, when we do reflections, is going to maintain itself as the reference angle through every reflection in the x and the y axis that you can do. And now I could either take this point, which I've reflected from here to here, so I can do a double reflection. I can reflect first in the y, then in the x. I could also reflect first in the x, then in the y. Either way, you're going to wind up at the same point, and we'll have the opposite of x and the opposite of y for our values that we started with as just x and y in quadrant 1. And when we bring that terminal line down, this angle right here is still going to be theta. Theta will be the reference angle. The quadrant 1 positive acute angle will maintain itself as the reference angle throughout this reflection process. And what you notice is if you start with a point in quadrant 1, you can generate 3 additional points via reflections, and you generate angles that go with them. You generate this angle right here is the angle 180 minus theta. We generate this angle right here, which is going to be 180 plus theta. And then we generate this angle right here, which is going to be 360 minus theta. So we generate 3 points and 3 angles by reflecting x and y in the y and x axes. So now we can look at the special angle context. So earlier we developed the idea that if we have a 45, 45, 90 triangle with a hypotenuse of 1, that the two side lengths were root 2 over 2 and root 2 over 2. And what we can do is take this angle and move it into the xy plane so that it's in standard form. The vertex is on the origin, and we have initial side and terminal side. And because the hypotenuse is 1, this point will land on the unit circle. This is a circle of radius 1. I have a hypotenuse of 1. That hypotenuse pops me out onto the unit circle. And this is a pi over 4 or 45 degree angle. And so just like we did on the previous slide, we can use this point, this known point, to generate 3 additional points. I can reflect this point over the y-axis. It will land over here, and I will get the point. Now the x-coordinate will be negative, and the y-coordinate will remain positive. And notice that corresponds to a terminal side right here, and we could actually calculate this angle. This is going to be 45 degrees, 2 45 degrees, 3 45 degrees. So we'll get a 135 degree angle if we sweep all the way through. 135 degree angle. Or if we're in if we're using radians, pi over 4 will be 1 pi over 4, 2 pi over 4, 3 pi over 4 by counting the fractions of the upper half circle that we have. This point can also be reflected down here. And this will give me the point positive root 2 over 2 comma negative square root of 2 over 2. I wind up with the terminal side right here. And this point can be reflected over to here. This point can be reflected down to here. They wind up in the same spot. This terminal side reflects through to here. And the x-coordinate is still negative, the y-coordinate is negative, and we could get the angle on this by saying, hey, this is going to be 45 degrees 5 times. There's 1, 2, 3, 4, 5. Or it's going to be 1 pi over 4, 2 pi over 4, 3, 4, 5 pi over 4. So this angle sweeping through here would be a 5 pi over 4 angle, or 45 degrees 5 times. And this would be 5 pi over 4, 6 pi over 4, 7 pi over 4, 7 pi over 4, with the reference angle of pi over 4. So we can generate additional points and additional angles by reflection. And we can do the same thing with our 30, 60, 90 triangle. We had a 60 degree and a 30 degree. And the idea here is we can either orient it with the 60 degree angle at the origin, or we can orient this with the 30 degree angle at the origin, so that this is a 60 and this is a 30. So in this case, this is an angle of pi over 6, which corresponds to an angle of 30 degrees. So we have the 30, 60, 90 triangle oriented this way, starting at the origin, and we can again reflect. We can reflect this point across the axis, and that's going to generate the point negative root 3 over 2, 1/2. And if we wanted the angle that was going with that, we'd recognize that the 6, dividing pi by 6, you're taking pi and dividing it into 6 pieces, means that we're dividing the upper half plane into 6 equally sized chunks. So it's going to be 1, 2, 3, 4, 5, 6 equally sized chunks. So the angle is going to be 1 pi over 6, 2 pi, 3 pi, 4 pi, 5 pi over 6 would be the angle that we rotate through to get to here. Notice if you did one more rotation, you get 6 pi over 6, which reduces to pi radians, which is a half revolution. Or we could take 30 degrees times 5 is 150 degrees to get this angle right here. And then we can reflect this point down like we did earlier. And this is going to be positive square root of 3 over 2. But now the y-coordinate is negative. When you're reflecting this over the axis, this reference angle here is going to be pi over 6. So the angle sweeping through from here is going to be pi over 6 short of 2 pi. So we could just get it by going 2 pi minus pi over 6, get a common denominator, and that's going to be 12 pi minus pi all over 6 is 11 pi over 6 for the angle, 11 pi over 6. And we can reflect either of these 2 points down over the x or the y-axis. So reflect it down, land here. Now both coordinates are negative. Terminal side sweeping through into here. This is 5 pi over 6, 6 pi over 6, 7 pi over 6. So this angle right here would be 7 pi over 6. There's 7 pi over 6s, or 7 30-degree angles. So we could also do 7 times 30 degrees is 210 degrees. That's horrible. 210 degrees. And this, then we already got that angle, so we could play the game one more time, but this time orienting the 60-degree angle right here. So pi over 3 is the 60-degree angle. That puts the 30-degree angle up high. And so the x and the y coordinates are going to be reversed, right? The short side, the 1/2, which is the x coordinate, has to be opposite the small angle. And the larger number, root 3 over 2, has to be opposite the 60-degree angle. Whereas when we were down here with the 30-degree angle located here, and the 60-degree angle located here, we had to put the root 3 over 2 first and the 1/2 second, because the height is shorter than the width. But again, we can play the same game. We can reflect to get additional points. So the pi over 3 just means the upper half plane's been broken into 1, 2, 3 chunks. We reflect this point across. The x coordinate will now be negative. If I want to know that angle, I recognize the upper half plane's been broken into 1, 2, 3 slices, and I have 2 of those 3 slices, or in other words, we have 1 pi over 3, 2 pi over 3. This angle is 2 pi's over 3, or 2 times 60 degrees is 120 degrees. It's just 2 of whatever the reference angle is. It's 2 of whatever the reference angle is. Now to get another point, I can reflect this guy over the x-axis. He would reflect down to here. And the x-coordinate is positive, the y-coordinate is negative there. There's going to be a terminal side landing right here. It's going to be pi over 3 short. Right? These 2 angle measures are going to be the same. It's going to be pi over 3 short of 2 pi. So subtract pi over 3 from 2 pi, get a common denominator. So 6 pi minus pi all over 3 is 5 pi over 3. So this angle sweeping through like this would be 5 times the reference angle pi over 3, or 5 times the reference angle 60 degrees, which would be a 300-degree angle. And to get the last point, we can reflect either this point or this point down into quadrant 3. So if I reflect him down, there he goes. The terminal side winds up here. Both the x and the y coordinates are negative in this quadrant. This angle right here, I can count up to it if I want to. It's going to be 1, 2, 3, 4, 5 pi over 3. Or 5 times the 60 degrees. Put 1, 2, 3, 4. It's 4, not 5. That was it's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. And I knew that and was just being stupid. So you get 4 pi over 3. So 4 times the reference angle. Pi over 3 is the same as 60 degrees. So we could also do 4 times the reference angle 60 degrees, which would be a 240 degree angle to get to this point right here.